Right over here, we can see that we are going to find the table below, example 35. You are using the table below, shows the increase in weight of Somu, an orangutan born at the Eastern Plains Zoo. Draw a graph to show Somu's weight increase for the first 6 months. So this is the number of months, and that's the weight. So we want to draw a graph. So this is pretty straightforward. You are going to be putting this into a table. Use your CAS. So go to your CAS here, go to home, and you got your Excel spreadsheet that looks like that on part 4. So click on number 4. Let's call the first column M for months and the other one W for weights, wasn't it? I'm just going to have a look at the page so it's easier to see. And under months, we're going to do the first 6 months. So 0 months, 1 month, 2 months, 3 months, 4 months, 5 months, 6 months. And what is the weight? So we're looking at the weight is 1.65, 1.7, 2.2, 3.0, 3.7, 4.2, and then 4.8. For those who are doing further, this is probably more familiar. So at this point, you can now control doc, which is add a page, or control I, the number of the letter I, and you can add on a data and statistics. So we're going to look at it on the x-axis. This is your months, because that's the independent variable. So that's your months. So this is your 6 months here. And then we want to see how the weight changes over those months. So weight as in your y-axis. That tells us that's my picture there. So I'm just going to model that and take a picture. Here we go. We're going to go back here and let's paste that in. So this is our graph. If we were to plot the graph, that's what it should look like. Draw a graph to show the increase, and that's pretty much it. If you want to know what the equation is, you can go to Menu, Analyze, and you can go to Regression. Go to Regression Exponential. So show the exponential equation, and right there is my exponential equation. You can ignore the R squared. I just have it on for my further class, but in your case here, you can now say the equation. I'm just going to pop it underneath so it's possible to see. This is the modeled equation, and so based on the data we have, the best model they've got there is weight will equal to 1.5529. Let's just round it to 4 decimal places. If we do that, then it should just be 30 actually. Yeah, we'll do that. 30. 3 decimal places multiplied to 1.22 or 28. Maybe we'll just do 28 to the power of x, which is the months. There you go. So the number of months, you can then model it based on this formula. All right, and that's all you have to do for fitting the data using spreadsheet on CAS. So with that model now, you can kind of predict what it should roughly be. Say if it's more than 6 months. So if you want to work out for 12 months, you can use this formula here to predict it. But I don't think the question's asking for that, are they? No, they just want us to sketch. Okay. I guess if you were to do this by hand, you can also do it by hand with the 2 coordinates. You can use what you've learnt previously, where you can do y equals to a times b to the power of x as your model. And then you can substitute 2 points. So you can substitute 0, 1.65, and you can try 1 and 1.7. Okay, so actually you can probably do that on a CAS. Let's go to our CAS and just type that in. Oops. Let's go Control I. Calculator, let's do solve, and we're going to go to our common catalog next to the 9, and we're just going to put in 2 equations. Here we go, our 2 equations. We've got when y is 1.65 is equal to a times b to the power of 0, because that's when months is 0. And then the weight will be at 1.7 a times b to the power of 1. Solve for comma a, comma b. And, That's slightly different. Ours is 1.553 on approximate, and this is 1.03. And I guess it just depends on which 2 points you pick, because it's not a perfect exponential graph. So you'll probably find that it'll vary if you picked another coordinate, for example, because it's an approximate. If I picked another coordinate, say it will be 3 kilos in 3 months, because that's what it says there, then you can see that it's got 1.65 and 1.22. If you tried say the 5th month, which is 4.2, and we'll try 5. Oh, that's 1.2. So you can probably say it's in the 1.2 region. Yeah, probably go with 1.2. That's probably a good measure if you wanted to calculate like a model for it. But look, all of them, the best one would be the one that I've done a exponential regression for you. But if you were to just pick 2 points and because they didn't say it's an exponential equation, we're just modeling it, and obviously the model has errors. You can say that the equation could also be, or it could be weight is equal to 1.65 multiplied to, say, 1.205 to the power of m. That's also another one too. Okay, so it depends on which points you want to pick, but I would say the best one, this is the best model because it's the regression line. Okay, there you go. So that's how you use your CAS spreadsheet to graph it, but that's the last example, example 35.